So main challenges in machine learning. What are the data issues? Means actually why machine learning has become so powerful because we have huge data. So like it gives example like our eye means if you have to train a kid, oh this is apple, you just show him apple and okay he got it. But machine you have to feed him millions pictures of apple to tell it it's apple because for machine some task which is easy for humans is very difficult for machine to like understanding apple you have to feed lot of images to machine so that it knows if this is apple, this is banana, this is things. So one thing is if you don't have good data, insufficient data, that's the problem. Non-representative data. It gives an example of a election, like 1929, 1913. The election was held, and a company sent kind of they send what you call surveys to million people, so a lot of people, 100,000 people, and they came okay that Republican candidate will win. They were very sure, but what happened? Democrat win, and they found out all the people whom they sent surveys were the people who were listed in some telephone directory, they part of some libraries, and those were very most of the well-off rich people who vote for Republican anyway. So there was a bias, their data was bad, and that's what there could be noises in your data, there could be errors, outliers. Outliers means some people were very rich, they may vote differently than the people who are earning regular salaries. For them, inflation could be high. So if you are reaching or surveying very top, if you're feeding data to machine which is not normal, as we said in diseases, you can have some complicated issues and your length of stay could be very huge. Your cost could be huge. And if you're feeding that outlier data to machine, it's not going to work. Irrelevant features. So yeah, Nivedita, you want to talk about data issues? Yeah.
Um, yeah, I mean those are on my on the screen. Those are the main data issues. But like bias, you said that's a big challenge in the machine learning model. So bias usually happens when your machine sees an apple, your machine sees an apple, an orange, and banana, and all of a sudden you are getting a watermelon and say get like what is that? How can a machine learn? Okay. So that happens when machine did never seen a new data. That's when an overfitting or bias, like overfitting or underfitting bias or variance happens, and that's because of the true limit data and maybe true limit and data quality is not good. A lot of noise, error, outliers. You said outliers is always like the fast, fast, less than minimum and greater than maximum. So, like in a company, in company-wide valuation or feedback times, usually say, okay, get the feedback from the employee or the regular employee. But outliers are those are like very in the top, like CEO, CTO. Those are like outliers. And the minimum outliers, those are entry level people. They don't know anything about the company and they just joined. And if you are taking review from feedback from those guys, then what will they tell? And if you are asking a CEO of the company, you give the feedback. How does a CEO knows what a regular employee does in the
You
company?
know,
We are spending 8 9 hours over there. We are working hard, and he doesn't know who is this employee, how much hours he is working. So those are kind of outliers. So we don't consider those people in the data feed. So data should be very quality. If the quality is less, then you will see noise and errors in the model, and model doesn't read them properly.
good.
So that's how you mentioned over here. Another is irrelevant features. That's a good one. I missed it. So irrelevant feature in the company example, the feature is whether the employee have spouse or children. What to do with the spouse and children in the data feed? So data should be employee, employee's age, and employee salary, and that says the feedback. If you add the employee spouse, number of children, that doesn't help. So they are the irrelevant feature. So you just have to remove them by asking the subject matter expert.
Grateful. And that logarithms, like logarithm issues, overfitting. So like it's like the real scenarios could be very complex. As Nivedita said, we trained our model, our machine learning logarithm to just apple or oranges and bananas, and just suddenly you give watermelon. So that's what like our logarithm is very general. It doesn't know something new comes and it cannot comprehend watermelon. Over That's overfitting. Like things are too complex. Like another example gives. We go to some country and that taxi driver charges us extra, and we say, "Oh, that country is full of cheat." That's overgeneralization. So that's another example of overfitting. And underfitting, I love the linear model, Nivedita. It's very simple. That's the easiest straight line. But as life is too complex, that straight line is not good enough for most of the scenarios. So
Mm.
that's logarithm issues. That's another debate. Does the logarithm matters? It's like, is data more important or logarithm more important? Nivedita.
Data is more important
Data.
always. Logic can be study, can be read through
Yeah.
books, and you can implement. Anybody can implement. But if you
Uh-huh.
don't have quality data, then never works. It's never
Yeah.
gonna work.
Yeah. TikTok, they are trying to find out the mechanism, right? How it works. Because they are trying to find the logarithm, right? In
Mm.
TikTok, but that's their recipes, right? It's for some companies,
Companies.
their algorithm. So testing and validation. So testing again is like software testing. Whatever I was reading, he says have a training data and test data, find out, make sure in supervised, of course, you will, that's what training and test data, you will cross validate, and validation set for model selection should be there. Basically, that's what we for model selection in when I was in the healthcare industry. As I said, they used to calculate a model to calculate the length of stay in a hospital for a patient, his cost for all his procedures. Once they build a logarithm, they used to run real life examples, which has happened in the past. Like, okay, this model is calculating correct or not, and some kind of variation is okay. How much variation is okay? So that is called validation. So how, Anurita, how do you validate your machine learning in fraud? Uh,
Mm. Yeah, that comes under the cross validation. So there are many ways actually. In layman term, I can say you have a full data, you got a big data, and so fast to usually split them, the 80% data in the train and the 20% in the test. So we train the model, we usually show the model, see this is the train data, and how you work on the test data. If the model builds well, then it can generalizes well in the test data. Otherwise, it cannot find the patterns. I mean, this is totally new, right? And the validation usually happens in the same way. So that train test, split, train test, another like in bank, usually three splits. Here, train test, validation out of time. Four types also usually do. But the cross validation, there are k-fold cross validation um, and I mean there are many actually fast in, fast out cross validation. There are many. So we don't actually, because those are the thing usually done automatically. Also, there is a algorithm called extreme gradient boosting algorithm. It's kind of tricky. XGBoost it's called, and that algorithm does everything by itself, like feature selection itself, splitting, cross validation, performance, everything by itself. So usually use that. That's kind of little tough, but yeah, cross validation by manually usually do by k-fold cross validation, min max. There are many ways. Um,
Awesome. Nivedita, thanks for joining us. I think we are at the end of, let me see, any data mismatch and practical issues and summary, machine learning, learning from data,
mm,
not hard-coded rules, different machine types with different tasks, data quality and representative matters, balance overfitting versus underfitting, and testing validation. So that concludes our meeting. So uh, I want your feedback. How's our meeting go? I'm thinking the next chapter is very complex. I would recommend it's a hands-on exercise. I would recommend everybody to take it seriously and try it out. It will give us whole. We'll understand more. We'll get more benefited. And very thanks to Nivedita for joining us. We got some great insights from an expert. So Aditya, how you feel this meeting once in a month is a good thing?
Yeah, we can plan accordingly.
Okay, okay.
Yeah,
Karan, yeah,
really thanks
yeah,
to
Phil.
you and Nivedita for this nice session.
Karan, what are your thoughts?
Yeah, I think
How
once a month is good, or maybe we can do once every 3 weeks or something like that, so that we can do that.